Hi guys, my name is Arvindh. Welcome to 6th grade math with all STEM. Today, we will be discussing fractions and decimal operations. This video covers the basics of fractions and decimals, relationships between all types of fractions and decimals, how to operate with these numbers fluently, and understanding number relationships in word problems with fractions and decimals. As always, our videos consist between 8 and 15 review questions. Each one is timestamped in the description box. If you get a question right, feel free to skip to the next timestamp. Otherwise, go ahead and watch the explanation for each question. If you want to review certain topics after this video, we have a links for further reference page in our description box, along with all of our other questions. On this page, we have a link for each question so that you can dive deeper into the challenging ones. These links are great for extra practice. All right, let's get into the first question. So here are our topics for today. We're going to use visual models and common denominators to interpret and compute quotients of fractions. We're going to fluently divide using long division, fluently use the standard algorithms for the four operations, understand prime factorization, use rational numbers to describe quantities, understand rational numbers as points on the number line, understand ordering of rational numbers, solve real-world and mathematical problems by graphing points in all four quadrants, and apply and extend understandings of previous knowledge on addition and subtraction. So our first problem. Henry is using a polyurethane spray that can seal and protect several new dinner tables. It takes 2/5 of a can to seal and protect each table. He has 3 full cans of spray. How many tables can Henry seal and protect? So pause the video here, and in a few seconds I'll reveal the correct answer. Ready? 3, 2, 1. So to find the answer, we need to divide each can by 2/5. The final answer we get is 7.5 or 7.5. This means that Henry can seal and protect 7.5 tables or 7 full tables. So let's do this mathematically. So he has 3 full cans. I'm going to draw 3 boxes because I like to visually model. Now I'm going to split it into fifths. Okay, now each color will represent 1 can. So it takes 2/5 of a can to seal and protect each table. One table. Two tables. Three tables. 4 tables. 5 tables. 6 tables. 7 tables. And our half of a table. So using the shading method, we can actually see that there will be exactly 7.5 tables shaded in. And that was problem number 1. Let's do problem number 2. So, a group of 32 students have raised money to help pay for a field trip to the Outer Banks Research Park. The trip will cost $3,200 and they have raised $2,156. The students have to pay for the remaining cost of the trip. How much will each student have to pay? So take a few seconds to pause it now and solve the problem, and I will reveal the answer so we can check. Okay, ready? 3, 2, 1. So the final answer is 32.20, or each student must pay $32.20 so they can go on the field trip. So let's solve this. The first thing I want to do is find the difference between both of these values because that's how much money they have to pay now. So we have to do 3,200 minus 2,156. And I can solve this out now, but to save time, I will put it in my calculator. So I'm getting $10.44. Yep, $10.44. So there's 32 students. So this has to be split among those students. So each of them pays that value. So we must do 1044 over 32, which will give us 32.625. Oh, okay. So this answer is wrong. My bad, guys. This answer is wrong. It is actually 32.63. Because, yeah, I just put it in my calculator. 1044 over 32. Yep. It is 32.65. And when we write it in money notation, remember to round to the hundredths place. Okay? So we get $32.63. Okay, let's do problem number 3. So this is our little introduction of geometry for this unit. So, in Storybook Middle, the art students are studying geometry and art. Regina, a student in the class, is exploring triangles. For her assignment, she needs to design her shape, the triangle, and have it meet some geometric theorem or rule. She decided to go with an isosceles triangle. What length of wood must she buy to construct the isosceles triangle frame seen in the picture on the right? And that's referring to this space. What is the length of this that she needs to construct the triangle? So pause the video now and solve the problem, and in a few seconds we can check our answers. Ready? Okay. 3, 2, 1. The length needs to be 10 3/4 inches. So using our basic geometric rule, we know that an isosceles triangle has to have two sides that are the same and one side that is different. That is an A, by the way. Here, I'll make that a bit clearer to see. Okay, two sides that are the same and one side that is different. So, usually in all isosceles triangles, the base is oriented or positioned at the bottom. So that means it's the two sides that are supposed to be the same. So this one has to be 10 3/4 so that it can be proven that it is an isosceles triangle to meet the theorem that Regina needs to demonstrate. Let's do question number 5. The balance in Sue's checkbook was negative $12.56, and the balance in John's checkbook was negative $10.45. Write an inequality to show the relationship between these amounts. Who owes more? How do you know? Pause now and solve this problem. In a few seconds, we'll check our answers. Ready? 3, 2, 1. Sue owes more than John, and I will verbally say how I know. So, if you can see here, I made a diagram to represent this because it's just way easier for me as a student to kind of visualize problems through charts rather than through math, because I want to see what's happening before I actually write what's happening, you know? So this is Sue, and this is John. And how we know this is because of where the points are plotted. So let's identify 0 right here. So when we talk about numbers, pretty much the general rule is that the farther away from 0 you are, the more or less the number is. So the closer you are to 0, the smaller your number is. I'm sorry. That's talking only about the right side. On the right side, the closer you are to 0, the smaller your number is. On the left side, which we are talking about in this case because these two people's money values in their checkbook is on the left side. So the closer you are to 0, the higher the value of your number is. Okay? So pretty much, we have to, sorry, that took me a second, but pretty much we have to figure out whose value, which is seen here by this blue circle, is closer to 0, and that is the bigger number. So clearly it is John's, because John's is closer to 0 than Sue. So that means John has more money than Sue. Well, John has less money to owe than Sue. So, who owes more? Sue owes more than John. Yay, we made it to the last problem. Let's do it. The number line shows the record low temperatures for these North Carolina cities in the months of February. So there are 4 parts to this, but they shouldn't be too bad. A. How much warmer was the record low in Cape Hatteras than the record low in Boone? B. How much cooler was the record low in Boone than the record low in Greensboro? C. How much warmer was the record low in Winston-Salem than in Greensboro? And lastly, D. How much cooler was the record low in Greensboro than in Winston-Salem? Pause now, solve the problem, and in a few seconds we'll check. Okay? Ready? 3, 2, 1. A is 19 degrees warmer. B is 4 degrees cooler. C is 6 degrees warmer. And D is 6 degrees cooler. Oops, my bad. Okay, so let's solve these. So, how much warmer was the record low in Cape Hatteras than the record low in Boone? So we need to find how much warmer Cape Hatteras was than Boone. Pretty much warmer or cooler, we just have to find the difference. To find the difference, we do 11 minus negative 8. And remember, 2 minuses make a plus. So that's a 19. That looks like 1G. But yeah, that's 19. So yes, it is 19 degrees warmer. Now let's do number 2. Letter B. How much cooler was the record low in Boone than the record low in Greensboro? So here, we actually have to still find the difference. Yeah. So we have to find the difference between Boone and Greensboro. So we do negative 8 minus negative 4. 2 minuses make a plus. And our answer is negative 4. That looks good to me. Okay. Let's do C. How much warmer was the record low in Winston-Salem than in Greensboro? So Winston-Salem and Greensboro. Let's do it. 2 minus negative 4. Remember, the difference between Winston-Salem and Greensboro. That means Winston-Salem has to be first. Okay? 2 minuses make a plus. That is 6. Our answer is 6 degrees warmer. Last one. How much cooler was the record low in Greensboro than Winston-Salem? Let's do this. So, cooler. This, actually, let me solve it this way and then show how this answer also works. In Greensboro, then in Winston-Salem. Oh, Greensboro's not -6. Oh no, I cleared everything. Sorry guys, but it's okay. Let's do D, because everyone should have had, you guys should have been comparing anyways, so it's okay. -4 minus 2 equals -6. So I know our answer is 6. So how does -6 still work? Let me tell you this. I just solved for warmer. It's -6 degrees warmer. And since cold is the opposite of warm, +6 is the opposite of -6. So it still makes sense that it is +6 degrees colder. And that was problem number 7. Okay, let's do problem number 6. So the perimeter of a square is 22 units. One of the vertices of the square is located on the origin of coordinate plane, and another one of the vertices is located in the third quadrant. What are the possible coordinates of the vertices of the square? So pause now and solve, and in a few seconds we can check our answer. Ready? 3, 2, 1. Okay, so one of the answers that you could have gotten could have been -5.5, -5.5, -5.5, 5.5, -10, 0, and 0, 0. And I've graphed our points in Desmos right over here. And yeah, these are possible combination of coordinates that you could have gotten. So let's go over our geometry basics. So let's draw ourselves a little square. So each of these corners is known as a vertex, and the plural of vertex is vertices. Okay? So squares have 4 vertices. Now let's go over our coordinate plane rules. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So basically, when following the rules of this problem, we need to have one of the points at the origin, which is 0, 0, and another one of our points in the third quadrant right here. So here's another one of our possible answers. Okay, and we want to make sure that our perimeter is 22 units. So yeah, this is another one of our examples. So in geometry, there are just so many, I guess you can say, numerical combinations of values that will get you the same answer. You just have these rules, and you just want to make sure that you can meet all of them. And both of these examples meet these rules. So whenever you are graphing, make sure that the lines are straight, not like how I'm drawing. It's not very straight, but try your best, and yep, make sure that your answer checks out. I hope that this was a good review of these topics. Like I said in the beginning, make sure to check out our links for further reference for more practice on these topics. Did these questions help you out? Do you have any other questions? Let us know in the comments down below. If this video was helpful, please make sure to like, share, and subscribe. Thank you, and I hope to see you in the next video. Bye.